you have to pay attention today. You should pay attention every day, and then you wouldn't have to pay super attention on reports.
Alright, good morning guys. You will notice that there's a video camera back there. I have to video record you guys for my final presentation and turn it in. So just act yourselves. Don't no one will get up and start screaming, just
Does it like
to yourself.
show everybody in the room?
No, right now it's just focus on me. And maybe they can see it more. We're going to start the warm-up today with these two problems. They're similar to the ones we did online. And I'm going to have you guys try to help each other. So what I'm going to do is assign the first rows to be together. And then you guys are a group, 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 and you two can work together. So each work individually on these problems. And then when you finished both of them, go to the other people in your group and help them finish it. Once everybody's in your group is done, write your names up on the front board. And then when everyone's names are done, we'll start the review. The review is only a few slides, it's not going to take very long. And then you guys will get time to work in your Math Excel. So you guys can review for that. So let's start the warm-up now.
R for X. X equals R.
No, neither do I.
So it'd be R squared plus 8x R cosine.
I got like 20 out of 30
I was like, well, no, and then you can take out the R.
I got 60.
Then you get R, 8 R cosine theta, so then R equals 8 cosine theta. R times 8 R cosine theta. Did you try to go? No, it's time.
Yeah, R times R.
Yeah, so then it's just like this one. And then you get 8. I don't know.
There was one of my paragraphs that was like,
I don't know if that's right, so don't get me caught on something wrong.
wait, what happens? Because someone
I don't think you do.
R squared plus 8R cosine theta.
In this one,
Remember guys, from converting to polar, we just need to use those four equations. So look up there and make sure that it's pretty much a substitution when you work from green to polar. You got you.
oh wait, crap.
R times
You
R
won't know
plus
about
8
it.
cosine
it's just like
We can move to that side.
if you don't know
Yeah, R squared plus 8R cosine
then R squared equals negative 8x. And negative 8x. R cosine of theta. Can I get number 1 done? I know how to do the second one. Okay, so the first thing you do is set x plus 4 squared gets accurate. So then you get x squared plus 8x plus 16 plus y squared equals 16. Or it says x squared plus y squared is r squared, so you have x squared plus y squared. So those two together turn into r squared, which is 8. And you can subtract 16 and you get 0 on this side. So you you get r squared plus, or r squared, yeah, plus 8x over 0. And then you subtract 8x, so you get r squared equals negative 8x. And then if you look on there, it says x equals r cosine of x. So you get r squared equals negative 8 times r cosine of theta. So then you can take out r, so then you get r, and then 8r cosine of theta, and then, I don't know, I looked on one of my other answers, the r equals like 6. You want to write down that one. Okay, so then you can take out r squared.
It doesn't make sense.
So then you just like, I'll show you
Or if you find it.
I got number 2.
I'm grading them all on the test day. So if you didn't do it, that just means you missed a chance. I graded one.
So if after you grade it, like your approximately, like, tells me what if I done class today.
I haven't graded the second one yet because people do it late.
But like the first one, so like I got 70 on it the first time, so then I retook it. So I'll find out today what I got on it. Okay. Mr. Golden, well, I don't even know how to start.
So you know, you see a Y here. And before the test, so see, it says Y equals R. That's all we're gonna do.
I got the.
Me too. Lauren and I had we only missed 4 points.
I got this.
I asked her for different questions. One of them wasn't for. I remember that.
Oh, you'll always just substitute in those 4 questions. And I'm gonna go over that a little bit in the review.
I don't even know.
So you're able to do the R squared with X squared or Y squared. And then just
So I have to change Y first, I guess.
Yep. And then you can take that Where did you write down?
Okay, then what's there?
So see that X and the Y there? See the X and the Y in the corner? So that's, so we just kind of plug it in.
Then I'll tell you.
So initially when you get the number 2, it'd be
Are you
r equals negative 8 cosine theta.
Can you two go help the other kid?
You can tell me later. Yeah, and then I'll tell you why she
Hey, I'll try to for sure.
That whole side. Mr. Golden, one of your first ones?
Yep.
I got this far out and I don't know what you well, just subtract the word
So that's a, so sine equals or whatever.
So I have to write it all out like
So that's
Yeah.
a sine.
You move the 2r cosine over and then from the y side r out, so then you can get rid of the r.
Or if we do the same thing.
You move the 2r times cosine to the side, just by subtracting it. And then with that, you can factor out the r.
You get r equals.
Yeah, subtract the these and factors.
So then you r times cosine minus 2 or sine minus 2.
You did?
How did you figure that out?
And then you just divide by the r minus 2 cosine, or sine minus 2 cosine to get the r right.
I'm ready.
I love you guys' like soccer.
Jordan, write my name.
This would end up being
I got it, Joe. I like that too.
How'd the day go by?
So one more step.
Crazy stuff.
This is Caitlin.
Oh.
Yeah, how she did it. Yeah. I was like, wait, so what did you do?
You just need to solve for R. Subtract. See, she just substituted.
Oh my gosh, guess what? You know, it has that word signs for AP government, like that noodle thing that took you like 2 hours to do. Mine deleted on me. Mine deleted like I'm down. I'm down. I cried. I cried. I was like, I'm done, and I tried to delete it, and it logged me out.
You are too.
You're right.
Yeah.
This one was a little easy.
Honestly, this was not more.
You remember on the quiz, you have to put the potatoes in there.
Oh, okay.
No, that's honestly.
And she's like, shut up. Make me breakfast. And she's really mean.
Alright, so let's go over these two.
I recommend working like that. And then I
How do you get the rest of it? Like, why is the characters doing all of that?
I think I was pretty proud of myself.
Yeah, so.
Alright, so everyone pay attention and see if your answer agrees with the answer on the board. Perfect, good job.
I gotta do that revision thing. I don't. I have to do the journals. I don't know what's wrong. I literally read that book and was like.
Alright, so for these polar ones, for most of you, there's gonna be a breaking point. Either you don't know where to start, or you'll start and get to a point and you won't know how to continue from there. And with this type of question, it'll either be you don't know how to start, which can be solved by every single time you convert into polar, knowing that you just have to use these 4 equations. That's how you start, always. Unless you expand it out in here. But besides that one expansion, you're always going to start with these 4 equations. So that's what she did here. She started by saying y equals r sine of theta, substituting that in, and x equals to r cosine of theta, substituting that in. Then she just subtracted, and this is the step that gets a little bit confusing, going from here to here. Notice that at this point, after we took out the r from both terms, if I put in a number for theta, or a degree and angle, this whole term, these 2 terms would end up being one number. Let's say it was 5, for example. Then this would be 5r equals 3. If we had that, most of you would know and just divide by 5. So it's going to be the same here. We're just going to divide by all that. And that seems to be a little tricky. But this is just r times eventually some number. So we're just going to divide all that out to solve for r. Make sure you don't divide by r in this step. Some of you were dividing by r and then getting 3 over r. If we're solving for r, we never want r to be on the bottom. So if you ever see variables you're solving for on the bottom, know that you kind of made some mistake. Then for this next one, I'm going to have Allison go quick.
Oh, me too. Can we do it? I better get it.
I'll break it. Put that on your ITBS.
Good job. Alright guys, listen up for a sec. So, with this case, we need to expand, and I looked around, most of you got this one right by now, but there's one point I want to go over. This step right here. This is our final answer, and this is what you put down on the quiz. For example, by going from here to here, a mathematician would yell at you. Because you're technically dividing by a variable, you're dividing by r, which in some cases could get rid of solutions. For example, when I have x squared equals 9, or let's have x squared equals 9x. Divide by x, we get x equals 9. When actually there's another solution that we got rid of. So, because that's a quadratic, we have two solutions. So in this case, since this is a quadratic, it actually has two solutions. But this is okay to do in this case, and I'll explain why. And in this class, for these type of problems, you could just take out the r and divide it away. But I want you to understand why you could do that. That equation, negative a cosine of theta, is a circle that looks like this. The other solution to this problem, for those of you that kept the 8 on this side and factored it out, you got r equals 0. Did any of you get that? I think Caitlin got that.
Yeah.
Yeah, r equals 0 by factoring it out. So what r equals 0 means is r is the magnitude or the radius or whatever you want to think of it, shooting out from the center. So if r is 0, we're just going to be at the origin. And this circle already takes that into account. There's already a point at the origin. So it's kind of redundant. So that's why in this case we don't need to show the r equals 0 solution. And we could just leave it like this. But I just want to make sure you understand why. Any questions about these two type of problems? This is pretty much the extent that we're going to need to know about going from rectangular to polar. All good? Alright, then I noticed on the online quiz we did yesterday, or 2 days ago, alright, that was from the last class. I noticed from the online quiz from last time that polar seems a little bit abstract to some of you, that you're just using those equations and not really understanding why. So I want to make it a little bit more concrete. So to demonstrate between what polar and parametric really is, I'm going to need a volunteer.
No,
Alright, come on,
no, I don't like it. I don't like the other character.
It's alright.
I don't like it.
Come on,
Alright, so just stand on this little colored square here. Alright, so first, Creighton's going to be a polar. Yeah, you're going to be a polar coordinate. So all I'm going to say is this is 0, and I want you to walk like 45 degrees, 5 feet this way.
45 degrees. So where you are?
Around where I am, yeah. Alright, good, perfect. So now if I told Creighton to start from here, turn 45 degrees to the left and walk 5 feet, he could easily get to that part. Actually, just to make it a little easier, I'm going to say he walked 2 root 2 feet. And you'll see why. But 2 root 2 feet, that way. And then, so come back to the center here. So now he's back at the origin. Another way to get to this space is to first walk in the x direction 2 feet. Then walk in the y direction 2 feet. And you end up at the same place around. So that's the only difference between polar and parametric. Polar is saying, I'm going to show you how to get there by giving you an angle and how many feet to walk directly there. Kind of like the hypotenuse of a triangle, if you want to think of it that way. Another way you can get to the same place is instead of cutting corners, just walk in the x direction and then walk in the y direction. And the reason I said 2 root 2 is because 45, 45, 90 is 2 root 2. So that's why I did that. But thank you, you can sit down now. But that's all polar is an angle and a distance. And parametric is just the x and the y. That's all we're doing when we're converting. And that's how we get those equations too. If this is my polar graph, then the polar coordinate at this point, right here, would be 8, 60. And I ask you I want the parametric version of this point. And don't get confused between the jargon of polar and parametric. This is one way to get to that point. Go 60 degrees and walk 8. The other way, though, is if this is 60 and this is 30, we know based on our 30, 60, 90 triangle that this has to be half of that. This has to be 4. This has to be 4 root 3. And of course, you could just use your calculator if you forgot. Because we know sine of 60 equals y over r. And r is 8. So we could just do 8 sine of 60 to get our y. And notice that is that equation up there. 8 is r, and we're saying that r sine of the angle equals y. It just comes from the triangle. So if I give you a polar equation, the reason why we're converting this way is because we know that y equals r sine of theta for any triangle. And same thing down here, we know that x would then equal r cosine of theta. Because cosine of the angle is x over r. So if I want the polar coordinates, or sorry, the parametric coordinates, all you have to tell me is x equals 4 and y equals 4 root 3. And this is your parametric coordinates. And now if I want rectangular coordinates, just put them in a point. That's what you're most familiar with. 4 root 3. Rectangular, parametric, and polar. Does that help make it easier to understand what's been going on here?
Wait, which one is which? Is polar the coordinates?
Yep, polar is this. You can think of polar as it's a giant pole that's swinging around. Polar.
Wait, is parametrics the middle one, right?
Yep, parametrics. It's here.
What's the second one?
And then this one is rectangular. It's called rectangular, but that's what you've been working with since algebra class. You've just never been told it's rectangular.
Wait, what's the second one? The x equals 20?
That's the parametric.
Aren't parametric and rectangular kind of the same?
They are very similar, yeah. The only difference, if I was to give you a point, they'd be the exact same. With an equation, this is in terms of like t or time normally, and this one's in y is in terms of x.
But like they'd still be like x would always be the same as the cosine.
At the same point, yeah.
Okay.
All right. So I think this is fine for all of you. And now, if you get confused when I bring you an equation like this, it's no different than with points. Alright, so same thing with this. Now I'm giving you an equation, r equals a cosine of theta. A cosine of theta is this circle. Because we can see when theta is 0, when the angle is 0, we start out at 8. Cosine of 0 is 1, so we're starting out at 8. As cosine gets bigger, as cosine approaches as the angle approaches 90, then cosine of that angle gets smaller as it's approaching 90, which is why it's shrinking. And by the time it hits 90, it's 0. Cosine of 90 is 0. So from 0 to 90, we're graphing the whole top part of the circle. When we go past 90, now cosine is negative. Cosine of an angle past 90 in the second quadrant is negative, making us shoot backwards. So at this angle, we're shooting backwards, graphing the rest of the circle, until we're at negative 8, when it's cosine of 180. But at any point, we can graph a random point right here with a random angle and say that r, this distance, is just going to equal 8 times the cosine of that angle. That's our formula. That's what it gives you. So if I want the parametric version of this equation, in other words, if I want to graph this triangle and know what the x and the y is, how do you think I could do that? I think you could do that, Haley. If I want Holly, sorry. If I want the just the x part of this, what would I have to do to it? Multiplied by what? Same thing as the points. Exactly. Yeah. So if we know that our equation y equals r sine of theta and x equals r cosine of theta, then to get our x in our parametric, it would just be the r times cosine of theta, making our x parametric equation a cosine squared of theta. And then same exact thing for the y. If we just want the y part of this equation, for our parametric form, we're just going to multiply by sine. R is a cosine of theta times sine of theta. And we're done. This was the last question on the online quiz that you guys did last class. And a lot of you were trying to first get into rectangular and then get into parametric. And while you could do that, the parametric form you'd end up with would be some random t that wouldn't relate to this theta at all. So if we want to keep it in this, if we want to keep this theta in our parametric equation, this is all you have to do. You take the x part and the y part and put them together. And then this is your final parametric equation. Does this seem easier now than it did then?
Wait, what happened to t though?
Parametric just has to be in terms of some other function or some other variable. So like for example, this y and the x are both in terms of theta.
Oh, okay.
They could both be in terms of t as well. Alright, then the last slide we have to go over before you guys start your own problem.